So I flew in from Australia the day before yesterday. And I'm not saying that I'm the most jet-lagged person here, but I would appreciate it if you could all just put in a little bit of effort to laugh at my jokes. That would really make things easier for me. So, the event loop. A couple of years back, here at this very conference, a guy by the name of Phil Roberts did a talk called "What the Heck is the Event Loop Anyway?" If you haven't seen it, I highly recommend you check it out. It's on the JSConf YouTube channel. It's pretty fucking exciting. Shit catches on fire. In case you haven't seen it though, it's a really good overview of the event loop, the different components, and how they work together. If you haven't seen it, we'll do a quick overview of the things that are relevant for today, and then we're going to do a bit of a deep dive into some specific parts of the event loop. So you can think of the event loop as like the main function of the browser. It's just an infinite loop. It's going to grab a task off the task queue, and it's going to run that task. Which is great, but what's a task? So a task is how JavaScript gets run. If we have a bit of a script tag like this, we can see a bit of JavaScript in there. The browser's going to parse this script tag, and it's going to create some tasks. So the code with the dark background is going to be a task. When it gets run, it's going to create a variable, it's going to do something, and it's going to register this event listener. And then whenever the browser gets a key down event, the bit of blue is going to run as a task. So every bit of JavaScript that runs as a task, it could be a script, it could be a callback. What does execute task do? Look, it just runs the code. It's really not important. If you want to know, watch Phil's talk. But what about the task queue? That's what we're going to talk about today. We're going to have a look at task queues in the context of browsers, and we're also going to have a look at Node, and we're going to have a real quick look at web workers. Cool. So what's a task queue, and what's it for? So your task queue is where your code goes where your JavaScript goes while it's waiting to execute. So like before, we could parse a script tag. We could have a callback on a click event. We could have a callback on a set timeout or an XHR request. They're all going to go into our queue there, and they're going to get executed. The important thing is it's a queue, so things are going to get executed in the order that they arrive, first in, first out. The other important thing is that a task is going to run from start to finish, right? There's no interrupts in JavaScript. We don't have to worry about concurrency or locking or synchronization or any of that rubbish. It's super easy. Cool. So that's our event loop. It turns out, though, it's a little bit more complicated than that. You see, the task queue works in conjunction with the rendering pipeline. The rendering pipeline is what's responsible for painting things in the browser window. So you make changes to the DOM, you update your style, then the rendering pipeline runs and shows it on the screen. So the rendering pipeline can run after a task finishes. Task finishes, rendering pipeline can run. But browsers are pretty clever, right? And they don't like to do work that they don't have to do. And there's really no point running the rendering pipeline unless the screen's about to refresh. So your average screen, right, refreshes 60 times a second, once every 16 milliseconds. So if we run a task, the rendering pipeline is going to wait that 16 milliseconds before it runs. If it's not obvious, this is a slowed down version. It turns out it's hard to see things at 60 frames a second. Obviously, sitting around doing nothing all that time is a bit of a waste. So in reality, the browser is going to run a bunch of tasks and then run the rendering pipeline. The important thing here, though, is that the rendering pipeline can't run until the task finishes. So if you've got a task that takes a really long time, the rendering pipeline has to wait. A couple of milliseconds here and there probably isn't going to matter, but if you've got tasks that take a lot more than 16 milliseconds, your web page is going to start dropping frames. It's going to start running like this. If you do have long-running tasks, you can split them up. So you can create new tasks using something like set timeout. You can just run the first part of your task and then run the rest later on. Or you can use web workers, because that's literally what they're for. So now our event loop looks a bit like this. We're going to run an infinite loop. We're going to pick a task off the task queue, and we're going to run that task. And then if we're ready to repaint, we'll repaint. So that's cool, right? It turns out, though, it's a little bit more complicated than that. If you have a look at the spec, which I'm sure we all do in our spare time, you will see that an event loop can have one or more task queues. Now, I have to say, at this point, I thought what I'll do is I'll have a look at some actual browser code. I'll go in and I'll see like how Chromium does task queues, how it manages them, whatever. But I have to level with you. I'm a JavaScript developer. And it turns out that C++ is mostly punctuation and the word delegate. No idea what's going on there. So instead, we're going to look at a theoretical browser with multiple task queues. Now, to be clear, this is actually the example that's given in the spec of having multiple task queues. So it's not like I just made it up. Somebody else made it up. So this browser, it prioritizes mouse click events. So it's got two task queues there. It's got one where our mouse click events are going to go, and it's got another queue where everything else goes. And this is real simple. It's just like the business class line at the airport. It's going to run all of the tasks in the mouse click queue, and then it's going to run the task in the other queue. It doesn't affect the rendering pipeline. That's still going to run after each task if it wants to. Cool. So that's super simple. It doesn't have to be like that, right? The browsers can actually execute the queues in any order that they like. So we could have taken 2 off the mouse click off the mouse click queue, and then 3 off the other queue, or whatever we like. The queues can be executed in any order. But the queues do still have to be queues. So the tasks have to be executed in the order that they arrive, first in, first out. Also, tasks from the same source have to go in the same queue. So all of our mouse click events have to go in that queue. Node, for example, uses a specific queue for timeout events. So all of the timeout events have to go in that queue. So this is how our event loop looks now. We've got an infinite loop. We're going to pick a queue. We're going to grab a task off that queue and run it. And then if it's time to repaint, we'll repaint. Cool. So this is still pretty straightforward, right? It turns out it's a little bit more complicated than that, though. We also have microtasks. What's a microtask? For the purposes of this 20-minute talk, a microtask is a promise. So there are other things that generate microtasks, but like 99.9% of the things you're going to do, it's going to be promises. So our microtask queue is in yellow there, next to the rendering pipeline. And we have a bit of code. It's going to run. We have a promise that resolves. It goes in the microtask queue. Now, the microtask queue has a couple of special properties. First of all, it runs after every task. So you finish a task, then you run the microtask queue. Even if the rendering pipeline would like to run, it has to wait until the microtask queue finishes. If we have multiple tasks in the microtask queue, they're all going to run. And if we add more while we're running it, those all have to be run too. So this has some important implications for how things run. Let's have a quick look at the difference between how tasks run and how microtasks run. So this bit of code generates tasks. I'll click the button. It's going to print out the number of tasks that it has run, and then it's going to generate another task, which is going to print out the number of tasks it's run, and so on and so forth infinitely. You can see we can start it running. It's counting tasks, but everything is great. I can still interact with the page. I can select text. I can click stop. I can't click start again because I didn't implement that. But if we look at the same thing with microtasks, things are a bit different. So if I start, so this is the same code, right? It's creating a microtask, which is going to print out the number of microtasks that have run, and then it's going to create another microtask. And it's just going to keep looping. The same as the set timeout example, but with promises. So if I click start promising, we can see immediately everything has gone to shit. The button has clicked, but it hasn't unclicked, right? The cursor, which you probably can't see there, it's still the little hand. I can't select text. I definitely can't click stop, which wouldn't have helped because I didn't implement it anyway. It's like I knew what was going to happen. This page is kaput. If we wait a little bit longer, Chrome will realize and tell us, but I don't have that kind of time. Cool, so what happened there? Exactly like we saw in the example, we're stuck just dealing with the microtask queue. So the rest of the event loop is blocked. We can't re-render the page. We can't do anything else. We're just stuck in the event loop, stuck in the microtask queue. So, yeah. Cool, so this is how our event loop looks now. It's still an infinite loop. We're going to pick a queue. We're going to pick a task off that queue, and we're going to run it. And then, as long as there are microtasks to run, we're going to do microtasks. And then once that's done, if it's time to repaint, we'll repaint. Cool, so this is starting to look a little bit complicated. But it turns out it's actually just a little bit more complicated than this. So we also have the animation frame callback queue, which I'm going to call the animation queue, because if I keep saying animation frame callback queue, this talk is not going to get finished in time for lunch. So you can add things to the animation queue by calling request animation frame and passing it a callback. Why would one do such a thing? Well, I'm using it here to run the animation of the browser running into the browser window running into the pipeline. So I have my browser window and my pipeline. I remove a class, which resets the frame. And then I add the slide class to the window, which gives it which makes it slide down through the magic of transitions. If I did it like this, like I said before, browsers are clever and they like to be helpful. If I wrote this code, the browser would look at it and say, you've removed the class, and then you've just added the same class back again. That's the same as doing nothing. So let's just do nothing. So instead, I have to make sure that the things occur after. So I need to do one. I need the browser to the window to refresh, and then I need to do the next thing. We have a look at how that works. We've got our animation queue there in green beside the rendering pipeline. So I've got my scripts running, and I call request animation frame, which adds something to the animation queue. You can see it's going to sit there, and nothing's going to happen until we're ready to repaint. Then we'll run the animation queue, and then we'll repaint the browser. Like the microtask queue, the animation queue has a couple of special properties. So if I have multiple things in the animation queue when it's ready to run, I'm going to run all of those things. But if I add more things to the animation queue while it's running, I'm not going to run those guys. The reason for that is that if you're creating animations, you want to say, this is what I want to do in this frame, and then you want to set up what's going to happen in the next frame, but you don't want to run it, right? You want to wait until the window's refreshed. Cool. So this is what our event loop looks like now. It's an infinite loop. We're going to pick a queue. We're going to grab the first task off that queue, and we're going to run the task. Then, as long as there are microtasks, we're going to run all those. Then, if we're ready to repaint, we're going to grab all of the animation tasks that are currently in the queue, and we're going to run all of those, and then we're going to repaint. And that is as complicated as it gets. But what about Node? Well, first of all, some good news. Node is a lot simpler than a browser. It's got no script parsing events, right? You're not picking JavaScript out of HTML all over the place. You just give it a JavaScript file and it runs it. There's no users clicking on shit all over the place. You don't have to worry about animation frame callbacks because there's no rendering pipeline. There's also another important difference with Node. The browser event loop is like a merry-go-round. It just keeps going round and round and round and round. The Node event loop, it's more like a roller coaster. It's going to run through one loop. Then there's more stuff to do. It'll run through another loop. But once it's done, that's it. It's done. So the node event loop. Node has 3 queues that are interesting enough to talk about today. It's got one queue for all of your event callbacks. So your XHR requests, your disk reads and writes, all of that kind of stuff is going to go in the first queue. The second queue, they're called phases in Node. So the second phase is the check phase, which I will get to in a minute. And the third phase is your timers. So that's all of your callbacks for set timeout and set interval are all going to go into that third queue. So Node is going to run everything in the event callback queue. It's going to run then everything in the check queue. Once that's done, it's going to run everything in the timer queue. And then if there's more stuff, it'll loop back around and run through the queues again. But as soon as there's no tasks in any queues and there's no events waiting anywhere, it'll just it'll finish. It'll end. So how do you add stuff to the check phase? You can add things to the check phase queue by calling setImmediate and passing it a callback. SetImmediate is basically the same as setTimeout with a time of 0. But because of the way the queues work, if you call setTimeout with a time of 0 and you call setImmediate, your setImmediate is going to run first. Cool. Node also has promises, just like the browser. And Node promises work just the same as browser promises. After each task finishes, we'll run the promise microtask queue. Super easy. Node also has another microtask queue, which is the next tick queue. You can add things to the next tick queue by calling process.nextTick and passing a callback. It works just the same. There's nothing really interesting there. The major difference is if you have both promises and next tick callbacks, all of your next tick callbacks will run before any of your promises. But that's pretty much it. So the only really new things, different things in Node are setImmediate and process.nextTick. If you have trouble remembering how they work, it's easy. SetImmediate does something on the next tick. Process.nextTick does something immediately. Simple. Why are they named like that? It turns out naming things are hard. You guys all know the 2 hard problems in computer science, right? Cache invalidation and naming things, and off by 1 errors. So this is our node event loop. It's only going to run while there are still tasks. It's going to pick a queue. And then while that queue has more tasks, it's going to grab the next task in that queue. It's going to run that task. Then while the next tick queue has more tasks, it's going to run all of the next tick queue tasks. And then while the promise queue has more tasks, it's going to do all the promises. So that just leaves web workers. Anyone who's not familiar with Australian wildlife, this is a redback spider. Unlike most Australian wildlife, they're not that dangerous. Nobody's died from a redback spider bite since the 50s. Probably don't get bitten by one, though. Cool. So web workers. Web workers turn out to be dead simple. Each web worker runs in its own thread. It's got its own event loop. It's got its own stack. It's got its own task queue. Everything just runs on its own. It's even easier than Node. So there's no script tags. Again, you just pass it a JavaScript file. There's no user interactions. Web workers aren't allowed to manipulate the DOM, so you don't have to worry about any animation frames or anything like that. If we have a look at a demo, we can see we can generate tasks. We can call setTimeout. We can make XHR requests. We can send and receive post-message events. So post-message is how your web worker communicates with the browser window. And we can make promises. That's it. It's just really easy. Yeah, so that's the event loop, right? Things to remember. Long-running tasks will make your web page run like a wonky cat. But promises and next tick tasks, they can make it run like a dead cat. So make sure you break your tasks up into small pieces and don't have infinitely recursive promises and next tick tasks. Node is a bit different to the browser. It's going to run through the event loop only as long as there are things to do. It's got those 3 specific tasks, and it's got setImmediate and process.nextTick. And web workers, they do their own thing, right? They're all in their own event loop. They're completely separate from anything else that's going on. And remember, the event loop is more exciting than you can possibly have imagined. Thank you.